Hello friends and welcome back to your channel GATEquestionsECE. I am back with next question in this series of random variables and the question code is 116. Consider n independent and identically distributed random variables x1, x2, x3 up to xn such that x1 is uniformly distributed over interval 0 to 1. If z is equal to maximum x1, x2, x3 up to xn, then find the expression of the following PDF and CDF of z. Probability that z is less than or equal to 1 by 2, expectation of z and variance of z. So let's see how to solve this question. So it is given that all these random variables x1, x2, x3 up to xn, all these are independent and identically distributed. So these are i.i.d random variables. And also it's given that x1 is distributed uniformly over interval 0 to 1. So we can write from this that the CDF of x for sample value small z will be 1 for range z lying in 0 to 1 and 0 otherwise. So the CDF we can write for x for sample value is small z, it will be integration of this. So it will be z in range where z lies in 0 to 1 and 1 for z greater than or equal to 1 where we can assume equal to time, and for all other values it will be 0. So these two are the PDF and CDF expression for x1. Since they are identically distributed, so all other random variables x2, x3 up to xn all will have same expressions for the PDF and CDF of random variables. So it's given that z is equal to maximum among all these n random variables. We know for the i.i.d case the CDF of z will be equal to the CDF of any of these random variable raised to power n. So we can choose any CDF, any marginal CDF of any of these n random variables. Here I have chosen the CDF of x1. So from this expression we can find out that this will be equal to z raised to power n for range 0 to 1 and 1 raised to power n, which will be again 1 for z greater than or equal to 1. And similarly the PDF of z will be equal to differentiation of this. So that will be n times the CDF of x1 raised to power n minus 1 times differentiation of this. That will be the PDF of x1. So now by putting the CDF expression here and PDF expression here, we can easily calculate the PDF of z. So that will give us n times CDF raised to power n minus 1. So z raised to power n minus 1 multiplied by the PDF, which is 1 in range z greater than 0 less than 1, and for all other values you can see it will be 0 otherwise. So this is the expression for the CDF of z and this is the expression for the PDF of z. So that is our part A. So now let's see what is the part B. In the part B, he has asked about the probability that z is less than or equal to 1 by 2. We know from the definition of CDF that it is nothing but the probability that capital Z is less than or equal to small z. So comparing this probability with this probability, we can see this will be equal to the CDF of Z for where sample value small z is 1 by 2. So we can put sample value small z is equal to 1 by 2 in the expression of CDF, and from there we can easily calculate this probability. So here putting z is equal to 1 by 2, we will get the required probability. So that will give us 1 by 2 raised to power n, which is nothing but 1 by 2 raised to power n. In GATE exam, the examiner may ask, by giving value of n is equal to 10, what is this probability? So in this case, that probability will be z less than equal to 1 by 2, that will be 1 by 2 raised to power 10, which is nothing but 1 by 1024. So such questions can be framed in GATE exams. Next, we will calculate expectation of z. That we know is equal to integration minus infinity to plus infinity, sample value small z, PDF of z dz. So here we will put the expression for the PDF of z. We know the PDF of z is non-zero only in range 0 to 1. So integration limits will modify from 0 to 1. So this will be equal to integration 0 to 1 z times n z raised to power n minus 1. This expression I have taken from our previous result of part A. So that will be dz. So that will give us n will come out of the integration, and this will be z raised to power n dz, 0 to 1. So this is nothing but n times, so integration will be z raised to power n plus 1 divided by n plus 1 limits 0 to 1. So putting these limits, you can calculate, it will come out to be expectation of z will be n over n plus 1. Similarly, just for the sake of practice, I am going to give you this expectation, say z raised to power some constant k. So let's calculate this. So this will be equal to integration 0 to 1 z raised to power k times the PDF, which is n z raised to power n minus 1 dz. So this will give us n integration 0 to 1 z raised to power n plus k minus 1 dz. So integrating, we will get integration of z raised to power n plus k minus 1 will be n plus k minus 1 plus 1 divided by plus k minus 1 plus 1 limits 0 to 1. So you can calculate this. This will come out to be expectation of z raised to power k will be equal to n over n plus k. In GATE exam, they may ask you expectation of z square for this case. So that will be n over n plus 2. So similarly, you can put different values of k and calculate expectation of z for higher powers of z. So now let's see what is the part D. So in part D, they have asked about the variance of z. So that we know will be equal to expectation of z square minus expectation of z raised to power 2. So this we have calculated just now. It was n over n plus 2 minus this is n over n plus 1 whole square. For example, in GATE exam, they may ask you for n is equal to 10, find the variance of z. So you can put here n is equal to 10 in this expression and calculate the variance of z. So let's calculate it. So variance of z will be 10 over 10 plus 2, that will be 12 minus 10 over 10 plus 1, that will be 11 whole square. So you can calculate this and that will give you the variance of that. So in this way you can handle any such problem on n independent random variables which are identically distributed and related by maximum function. Just for the sake of practice, I will like to give you a practice question. So this is the practice question in which x1 is uniformly distributed over interval -1 to 1 and all other things are same as we discussed in this previous question. So I will request you all to give a try to this question and try to solve this question, and if you find any problem you can mail me your solution on this GATEquestionsECE@gmail.com, my mail ID. So I hope you are learning from the discussion that we are doing. So if you are learning, then please do press that like button and subscribe to my channel for more such problems in future. And in the last, thank you for watching this video.